We walk through life assuming the ground beneath our feet and the stars above our heads are permanent fixtures. It feels like a solid, unshakable reality. But physics suggests that this entire structure could break apart without warning. That expiration date is tied directly to the Higgs field. Physicist Peter Higgs, seen here, helped identify this invisible energy field that gives all fundamental particles their mass, essentially holding our physical universe together. This chart shows how that field operates. The universe exists in what physicists call a metastable, or false zero state. Imagine a ball resting in a shallow valley. It looks like it's resting at the bottom, but it's actually elevated. It is sitting on a temporary energy floor, not the absolute lowest possible state, or true zero. Because this state is temporary, a random quantum fluctuation, or an extreme high-energy interaction, could be the nudge that tips it over the edge. If that happens, the universe plummets into the deeper valley, its lowest true energy state. That drop would release a cataclysmic amount of energy. The fundamental architecture of our universe is so delicately balanced that it could trigger its own erasure in a fraction of a second. If the Higgs field collapses into that true zero state, it creates a localized bubble of true vacuum. This bubble immediately expands outward in all directions at the exact speed of light. Because it moves as fast as light itself, no warning signal could ever precede it. We would never see it coming. Inside that bubble, the laws of physics as we know them cease to exist. The energy released would instantly vaporize entire galactic systems, completely wiping out our Milky Way before a single neuron could register the event. Our physical reality, with all its apparent permanence, operates entirely at the mercy of a sudden, undetectable cosmic reset. Let's assume a vacuum decay bubble doesn't suddenly swallow us. The universe still faces an inevitable thermodynamic wall. The most widely supported model is the Big Freeze, or heat death theory. As the universe expands, acceleration pushes galaxies further and further apart, slowly breaking gravity's grip on massive cosmic structures. Star formation will eventually shut down, leaving behind a dark expanse of dying stars and black holes. And as physicist Stephen Hawking mathematically proved, even those black holes slowly leak energy through what we now call Hawking radiation until they evaporate entirely. The absolute endpoint of this thermodynamic drain is complete zero. Zero light, zero sound, zero movement, and zero usable energy. A dead, frozen void. There are computing theories out there, like a big crunch where gravity reverses the expansion and collapses everything inward, or a big bounce that cycles between expansion and contraction. Yet regardless of the specific mechanism, the math points in one direction. The physical macro-universe is doomed to reach a final, static zero state. To understand why this ending is guaranteed, we have to look away from the vast scale of galaxies and peer into massive detectors, exploring the absolute smallest quantum building blocks of matter. Quantum mechanics reveals reality operates on a different underlying code. The classic proof is the double-slit experiment, first pioneered by British physicist Thomas Young. This animation shows the core mechanism. When particles like photons or electrons are fired through two narrow slits, they don't act like solid objects. They act like a wave, creating a complex interference pattern of multiple possibilities on the back wall, as long as nobody is watching. But the moment an instrument tries to measure or observe which slit the particle actually goes through, the wave pattern collapses. The simple act of measurement forces the particle to lock into a single physical location, creating just two rigid lines. This is known as the observer effect. At the quantum scale, reality acts remarkably like a computer rendering a video game. The physical environment exists as mere probabilities, only burning processing power to render solid matter when it is actively measured. If matter behaves like a stream of data awaiting a trigger, then the human brain represents the final link in the processing chain. It acts as the ultimate node where raw sensory information is gathered and interpreted. Your brain is constantly synthesizing a highly limited combination of sensory inputs, sound waves, visual light, chemical scents, into a single coherent narrative. This suggests that what we call reality is the output of this biological rendering process. At this scale, the act of conscious observation is what provides the necessary measurement to lock these quantum possibilities into the tangible physical matter we perceive. The world we inhabit isn't an independent, freestanding object. It is a temporary, subjective projection reliant entirely on the brain's ability to witness and process it. When we apply that quantum logic back to the macro scale, those massive cosmic structures, the stars, black holes, and sprawling galaxies, become unrendered pixels awaiting an observer. Heat death represents a slow drain of thermal energy across trillions of years. Crucially, this entropy also marks the final extinction of the conscious entities that serve as the universe's observers. This creates a final paradox. Without a brain to process the sensory data, the very foundation of physical matter has no mechanism to remain rendered. The universe's ultimate destruction may be less about the physical breakdown of atoms and more about the loss of the minds that gave those atoms form. Once the final observer vanishes, the architecture of reality simply dissolves back into